Hey guys, so today we are going to be solving for the total amperage throughout the circuit. So we are solving for IS, and IS is going to equal our voltage source, 10 volts, divided by our REQ. So now you see we have a bunch of parallel and series resistors together, so we need to break down the circuit into our REQ, so our total resistance. So let's start. You can see these three resistors are in series, so I'm going to start by adding them up because we can add up series resistors. I'm going to label that RA. So RA is going to be equal to R3 plus R6 plus R7. RA equals 6 ohms plus 2 ohms plus 10 ohms, which is going to be 18 ohms. And now I'm just going to put these together because you can see here there's a node here and a node here. And so they share the same nodes, so they're parallel. So I'll just label this RB. So RB is going to equal to R4 parallel with R5, and that equation is going to equal R4 multiplied by R5 divided by R4 plus R5 for only two parallel resistors. So 6 ohms times 7 ohms divided by 6 ohms plus 7 ohms is equal to, so 6 times 7 is 42 ohms squared plus divided by 13 ohms, and then just cancel out all the ohms. It's going to be 42 over 13 ohms. And so now, because we combined these two, it's going to be in parallel with R2. So I'm just going to color that red, and I'm going to name it RC. And RC is going to be equal to 3 ohms plus 42 over 13 ohms. That's going to be equal to, I'll just get a decimal approximation here real quick. 6.23. So now these two are going to be in parallel, RC and RA. So we have 6.23 ohms multiplied by RA, which is 18 ohms, divided by 6.23 ohms plus 18 ohms is going to be equal to 4.628 ohms. And so now you only have R1 left and this ohm left. And so that's going to be, so your REQ is going to equal to 4 ohms plus 4.628 ohms, and that's going to be equal to 8.628 ohms. So now to solve for IS, it's going to be equal to our VS, which is our 10 volts, divided by our total REQ, which is 8.628 ohms. And that is going to be equal to 1 1.159, and that's going to be amperage.